Hello, sir. Myself, Pial Shah from second year Electronics and Communication Department. My roll number is 34900 324055. Today, I will explaining some classification of signal, including continuity, periodicity, determinism, energy and power, and symmetry. These concepts are important for understanding how signals behave in communication system and electronics. In continuity, we can divide it into two parts: continuous time signal and discrete time signal. And a continuous time signal is defined for every possible time value. Example including voltage in a circuit or a sine wave over time. And discrete time signal is defined only at specific time instant and is represented as sequence of values of xn. Example daily temperature reading, stock prices recorded at market close, etc. And in periodicity, we can divide it into two parts: periodic time signal and aperiodic time signal. A signal is called periodic if it repeats itself after a fixed interval of time. In continuous times, this is when there is a positive constant capital T, such that x of t is equal to x of small t plus x of capital T. For all t here, capital T is period of the signal, and in discrete time it repeats after an integer n. Here xn is equal to x small n plus capital N. Here the example of periodic signal is sine wave. And if a signal does not repeat over time, it is called a periodic signal. Example, an audio recording of speech or random noise. In determinism, we can divide it into two parts: deterministic signal and random signal. A deterministic signal can be described exactly by a mathematical equation and its behavior is predictable. Example, a pure sine wave, and a random signal shows unpredictable variation and cannot describe exactly beforehand. Example, thermal noise in electronics. And if a signal has finite non-zero average power but infinite energy, it is called power signal. Example of power signal is a periodic sine wave, and a signal is called energy signal if it has finite energy and zero average power. Example, a short pulse. But some cases signals are neither nor energy power nor power signal, and it has infinite energy and zero average power. In symmetry, we can divide it into two parts: symmetric or even signal and non-symmetric or odd signal. A signal is even signal if it is symmetry about vertical axis, and even signal satisfied x of t is equal to x of minus t. Means if I reverse the signal, then the signal will be same. Example of The signal is cosine wave, and or signal are asymmetric, uh, and they satisfied x of t is equal to minus of x of t. And example of or signal are sine wave. And lastly, understanding these properties helps us analyze and design system for communication, controls and processing. Knowing whether a signal is periodic, deterministic, or an energy or power signal determines how we can process and utilize its